I'm going to show the update about what we did last time. There will be unfortunately no demo. It will be more of description what we've done. But yeah, like the non-technical updates is that we have another developer helping with lockc right now, Michał Jura. So it's developed by two Michałs right now. I submitted a talk for SUSE Labs conference about lockc, which I hope will be accepted, and we'll have opportunity to present the whole project to the more kernel-related part of the company. And lockc was already presented to Rancher Forks from K3's team. And about community-wise and public-wise, we have a website with documentation, which contains information how to build and use project. And we have a public Discord channel for anyone interested in lockc. We decided to pick the Rust Cloud Native Discord server because like the most of Rust people interested in Rust are currently on Discord. Of course, it can change. Of course, I wouldn't mind changing the place, but so far we've picked that Discord server. I can try to show you maybe the website itself. So it's Rancher, Sandbox, GitHub.io, lockc, and it's built with MDBook. Yeah, it has a short description of architecture and getting started guide with building the project, usage of it locally, and then there is a bigger guide about provisioning. And so far, the development environment can be provisioned using local libvirt, but there is also a possibility of using OpenStack to deploy the development environment on the cloud. And yeah, like there's a guide for building the base VM image. There's even optional possibility of building the custom kernel, because at some point we might need to add some LSM hooks or check if or debug kernel issues. We already had to do it once, and yeah, then there's a old Terraform method of spinning up VMs, which you all probably know from CASP times. And yeah, that's it when it comes to the websites. When anything more comes to describe, we will update the website, and yeah, we will treat it as the main documentation. There is also a code documentation which is auto-generated. It's docs.rs lockc. It's like auto-generated from the crate, and it's more about describing the single functions. It's not super detailed yet, but yeah, it's like what we get from comments on the functions. If someone is interested in like developing lockc, yeah, so that's the auto-generated information from the code here. So yeah, let's get back to the presentation then. And yeah, the major thing we are working since last time was development environments, and in fact it took us the majority of time, because honestly, like when I was showing you previous demo, I was mostly developing locally on my local node, directly on the host. I tried Vagrant, but it's yeah, it wasn't really reliable for me, and we decided to rather go with Terraform as in the similar way as it was used for CASP. And like the important reason why we chose Terraform with GuestFS rather than Vagrant is that, yeah, I had quite time using Packer for generating libvirt images. I'm mostly on Linux, and I would rather use libvirt, which I use for everything, rather than VirtualBox. And building libvirt images with Packer was quite tricky. I was receiving errors. I was asking on HashiCorp forums how to fix them, and didn't receive much feedback. And at the same time, like making VM images with GuestFS worked not natively with both with VirtualBox and libvirt format. And also, like, we decided to do provisioning, installing packages, like copying lockc binaries rather as a part of image builds rather than VM first run, like it's usually done in Vagrant. Yeah, and also important thing is that Terraform gives us possibility of using OpenStack and also maybe some public clouds in the future. And yeah, less important reason is that, yeah, if anything goes wrong, I would rather debug Go C and Python than Ruby. And yeah, like finally, developers can compile lockc locally with containerized build, then build the image and then use any flavor of Terraform they like to spin up VMs. And for now it's libvirt or OpenStack, but I will soon add VirtualBox and maybe if someone will want in future public clouds. And the other major thing which I was working for, but unfortunately I didn't get it done for the demo today, are mount policies, which I think will be one of the most important features of lockc. And the purpose of mount policies to allow baseline containers and restricted containers only from home or write data from host, and do not allow any bind modes from restricted containers, and allow mounting everything from a host only for privileged containers. Yeah, it's still in development. I expect to have a pull request somewhere this week. And the LSM hook used for that is SB mount, which can allow or deny a mount operation, and it's getting triggered every time the mount Cisco is used in the system. And we are mostly interested in those two parameters. We are interested in the def name, which is the source of mount, and type, which defines the type, because we want to filter out only bind mounts. And yeah, we need to make a decision for mounts to container mount namespace based on byte type and the path, the source path. And the problems to solve there were that def name is a string with the full path. I was optimistically thinking at the beginning that the construct path, which contains a hash of the directory, also is what we receive as a source path, but it's a destination. So the problem with that LSM hook is that you get source path as a string and path which contains also a new unique hash only for destination. I would rather, it would be more comfortable for me, honestly, if I was receiving both as struct path, but that's unfortunately not the case. With receiving hash, it would be much easier. But since we receive only string, we need to do string comparison operations. So what I'm trying to do right now is to define default list of allowed directories for which we can mount, and in that BPF program check prefixes. And here is how it works. Oh, I'm pretty sure I removed that if entry program for the slide, but anyway, lockcd is populating BPF map allowed paths with directories from which we allow to mount, and every time we try to mount, we check whether the prefix of the mount is inside the BPF map. If so, we allow. If not, we deny. we will be allowing var data, so that will be positive, and sysfsc mounting sysfsc groups for non-privileged containers, of course, something we won't avoid. So that's how it's that's how it's going to be implemented right now. And if resolving the path object would be possible in this LSM hook, it would be we could rather store hashes of kernel paths inside in BPF maps, and we would resolve those paths in LSM hook much faster, because we could pretty much do resolution like we check whether the full directory hash is in the map. If not, we go up. And then we check the hash of this one, and it is there, and we allow it. So it's like pretty much n times O1 operation, not like not n times n operations, ON operations like we do in the current approach. Seems a bit silly to fight so much for performance, but well, in kernel space in BPF programs, I would like to have as much performance as it's possible. But yeah, like we do what we can, so it's not possible, unfortunately. So the implementation will be rather this one. And next plans in general for lockc will be file system policies inside containers, so restricting containers from reading stuff even inside inside its mount namespace. Why? Because some directories like sysfs, btrfs, proxys, irq, defmem, and defsds are not namespaced. So even if you have the separate file system and mount namespaces for your container, you still see those directories and mostly see the same content which you would see on the host. There is no initiative in the kernel to make this namespaced, and there is no initiative from container runtime developers to restrict those somehow. So we will do that. And yeah, like one of the features of lockc which we planned would be like hiding those neuralgic directories which are not really needed for traditional applications from being accessed. And one other feature which I'm not sure whether will work out, but that's something to try out, is enforcing that in baseline and restricted containers we can't log in as root. The purpose of that would be enforcing people to define a custom user inside Docker file if they are just trying to run some traditional application, because being a root inside container is still like a risk. So yeah, that's something to try out. Maybe we'll decide afterwards that it's too much, and there are some justified examples of running root application inside non-privileged container, but so far I don't really see such a case. I would rather try to encourage people to use custom users in their local files. That's it for the presentation. Yeah, I hope it gave you some update on what we're working recently. Thank you very much.